To comply with California's 2016 Building Energy Efficiency Standards, or energy standards, buildings must meet all mandatory measures and the requirements of either the prescriptive approach or the performance approach. This course covers the prescriptive requirements for power consumption of fans used for space conditioning in non-residential, high-rise residential, hotel, and motel buildings. For an overview of the prescriptive approach, please see the course on this topic. The energy standards have specific requirements regarding the power consumption of fans used for space conditioning. Total fan system power consumption is calculated by summing the power consumption of all fans needed to operate the space conditioning system. However, total fan system power consumption excludes additional power demand caused by air treatment or filtering systems with final pressure drops more than 1-inch water column. Only the horsepower associated with a portion of the pressure drop exceeding 1-inch water column can be excluded. Total fan system power consumption also excludes fan system power caused solely by exempt process loads. If the total fan system power for a single space conditioning system or air handler exceeds 25 horsepower, the following requirements must be met. 1. For constant volume fan systems, the total fan power index must not exceed 0.8 watts per CFM of supply air. 2. For variable air volume systems, the total fan power index must not exceed 1.25 watts per CFM of supply air. 3. For air treatment or filtering systems with a final pressure drop of more than 1-inch water column, the adjusted total fan power index must be calculated using the Energy Standards equation 140.4-A. Let's look at this equation and see how to calculate an adjusted total fan power index for a laboratory filtering system. In this example, a 35 kilowatt fan is designed to have a flow rate of 40,000 CFM, a total static pressure of 5 inches of water column, and a filter pressure drop of 1.7 inches of water column. First, use this equation to calculate the fan power index. Convert the fan power, which in this case is 35 kilowatts, to watts and divide by the airflow rate, which in this case is 40,000 CFM. The resulting fan power index is 0.875 watts per CFM. Next, determine the fan adjustment value by using this equation. Enter the value of 1.7 for SPA. Next, enter the value of 5 for SPF. The resulting fan adjustment value is 0.86, meaning that 86% of the fan power index must be accounted for in the total power consumption. Lastly, use this equation to determine the adjusted total fan power index. Multiply 0.875 by 0.86. The result is an adjusted fan power of 0.75 watts per CFM. Next, we'll discuss additional requirements for variable air volume systems. Static pressure sensors used to control variable air volume fans must be placed in a position where the controller set point is less than or equal to 1/3 of the total design fan static pressure. If this results in a sensor being located downstream of major duct splits, a sensor must be installed in each major branch. Fan capacity must be controlled to ensure sensors in all branches meet their minimum set point. This requirement does not apply to multi-zone systems with direct digital control of individual zone boxes that report to a central control panel. For these systems, static pressure set points must be reset based on the zone requiring the most pressure. The purpose of this is to dynamically reduce the duct static pressure set point as low as possible while maintaining adequate pressure at the zone box with the greatest demand. Dynamically resetting duct static pressure saves energy by reducing fan power consumption. Now let's review the requirements for HVAC fan motors. HVAC fan motors that are equal to or greater than 1/12 horsepower and less than 1 horsepower must either be electronically commutated motors, also known as ECM motors, or meet the following requirements. 1. a minimum motor efficiency of 70%. Motor efficiency is rated at full load conditions according to the National Electrical Manufacturers Association, or NEMA, Standard MG1 2006. 2. The ability to adjust motor speed for airflow balancing or remote control. Belt-driven fans can use sheave adjustments for airflow balancing instead of a varying motor speed. There are 2 exceptions to the requirements for HVAC fan motors. 1. Motors in fan coils and terminal units that operate only when providing heating to the space served. And 2. Motors in space conditioning equipment certified under the Energy Standard's mandatory requirements for appliances or space conditioning equipment. This concludes our review of the 2016 Energy Standards requirements for the power consumption of fans used for space conditioning. To find more courses and additional information on the Energy Standards, please visit the California Energy Commission at energy.ca.gov. Thank you for watching.